Today we'll discuss ISI's MTech QROR PQA paper, and the first question is, we are given a parallelogram ABCD where these vertices are taken in clockwise order A, B, C and D. Now A is 1, -1, B is -2, 0, C is 1, 2, and we need to find vertices of D. Let these vertices be H, K. Now we know that diagonals of a parallelogram, they bisect each other. So that means midpoint of AC must be equal to midpoint of BD. Now what is midpoint of AC? Midpoint of AC will be 1 + 1/2 and 2 - 1/2, and it will be equal to midpoint of BD, which is H - 2/2 and then K + 0/2. Now if we compare its x coordinate, we'll get H as 4, and if we'll compare its y coordinate, we'll get K as 1. So the coordinate of this point D will be simply 4, 1, and that's your option number B. Now question number 2 is, we are given this locus where z equals 1 - t square plus iota under root of 1 - t square, where mod of t is less than 1. We need to find locus of z in the complex plane. So we'll compare it with x plus iota y. We can simply write x as 1 - t square and y is under root of 1 - t square. Now we'll replace 1 - t square with x. We'll get this as y equals under root x, which is y square equals to x. That is the equation of parabola. So basically this equation, it doesn't represent complete parabola, but it will represent part of a parabola. But we'll go with option B, and that is a parabola. Now question number 3 is, we are given this integral from 1 to 2 e to the power x square dx as a, and we need to find this integral, which is from e to e to the power 4 under root of ln x dx. Now what we'll do is, we'll take ln x as some t square, then x will be simply e to the power t square. Dx will be e to the power t square into 2t dt. So we can write this integral as, now under root log x is simply t, and then e to the power t square into 2t dt. Now what are the limits? When x is e, log e is 1, t will be 1. And when x is e to the power 4, t square will be 4, value of t will be 2. Now we'll solve this question using by parts. So let this be first function and let it be this second function. So here it will be t into, integration of e to the power t square into 2t dt will be e to the power t square. And then minus, from 1 to 2, it will be e to the power t square dt. Now this is 2 into e to the power 4 minus 1 into e, and then minus, and this integral, it is equal to a. So value of this integral will be 2 e to the power 4 minus e minus a, and that's your option number C. Now question number 4 is, what is the area bounded by the curve y equals e to the power x and y equals x into e to the power x and the y-axis. So we can draw the graph of y equals e to the power x. So that is the graph of y equals e to the power x. Now what about x into e to the power x? Now when x is 0, this value will be simply 0. And when x is 1, this value will be e. So at 0, this value is 0, and at 1, it will be e, and same as that of e to the power x. Now we know that when x lies between 0 and 1, x into e to the power x will be less than e to the power x. So this function will lie below e to the power x function. So we'll need to find this area. So this area will be this integral from 0 to 1, y of upper curve, which is e to the power x, minus y of lower curve, which is x e to the power x into dx. So we can write this as from 0 to 1, 1 minus x into e to the power x dx. Now we'll use by parts. So this is first function and this is second function. So it will be 1 minus x into e to the power x minus minus minus, it will be plus, and then e to the power x dx from 0 to 1. Now we'll put x as 1, it will be 0, and if we'll put 0, we'll get this minus 1, and then plus e to the power x will be e to the power x. So it will be E minus 1. So this area will be simply E minus 2, and that's your option number C. Now question number 5 is, we need to find set of all solution to this inequality. So what we'll do is we'll let 2 to the power x as some y. So it will be 1 upon y minus 1, and it is greater than 1 upon 1 minus y upon 2. So we can write this as 1 upon y minus 1 minus 2 upon 2 minus y, and it should be greater than 0. So if we'll simplify, we'll get 2 minus y minus 2y plus 2 upon y minus 1 2 minus y, and it is greater than 0. So it will be 4 minus 3y upon y minus 1 2 minus y, and it is greater than 0. So if we plot it on a number line, then the roots are 1, 4 by 3, and then 2. Rightmost is plus, so it will be plus, minus, plus, and minus. So we'll get the condition that the value of y, it should be either between 1 and 4 by 3, or value of y should be greater than 2. Now y is 2 to the power x. So we'll put y as 2 to the power x. So we'll get 2 to the power x should be greater than 1 but less than 4 by 3, or 2 to the power x is greater than 2. Now from here we can write this x should lie between 0 and log 4 by 3 to the base 2 union, and here we'll get x should be greater than 1. So it will be from 1 to infinite. So answer to this question will be from 0 to log 2 4 by 3 union 1 to infinite, and that's your option number D. Now question number 6 is, we are given this limit, which is limit x tends to 0 a into e to the power x minus b cos x upon x, and it is equal to 5. Now answer is non-zero finite. Now first thing that we'll check in any limit is its form. So we'll put x as 0, we'll get a minus b upon 0. Now a minus b upon 0, it can only be an indeterminate form if a minus b is 0. So the first condition that we'll get is value of a minus b must be equal to 0, that is value of a must be equal to value of b. Now when it is 0 upon 0 form, we can use L'Hopital's rule. We can write limit x tends to 0. Now it will be a and then e to the power x and plus b sin x upon 1, and it should be equal to 5. Now we'll put x as 0, we'll get a equals 5. Now a is equal to b, that means for both a and b value is 5. So answer is a and b are uniquely determined, and that's your option number A. Now question number 7 is, consider 4 events P, Q, R and S such that if any of P and Q occurs, then either R occurs or S does not occur. If exactly one of R and S always occurs, then which of the following statement is necessarily true? Now the first condition says if any of P and Q occurs, then either R occurs or S does not occur. So that means P union Q, it is a subset of R union S complement. And the second condition says exactly one of R and S always occurs. So that means this S complement is actually equal to R. So from here we can say that P union Q is a subset of R. Now P union Q, it is a superset of Q. So Q is a subset of P union Q, and which is a subset of R. So from here we can say that complement of R is a subset of complement of Q naught. So that means not R implies Q naught, and that's your option number D. Now question number 8 is, we need to find particular solution to this differential equation. We can write this as dy by dx, and it will be e to the power 5x into e to the power 7y. So we can write e to the power minus 7y dy equals e to the power 5x into dx. Now if we'll integrate, we get e to the power minus 7y upon minus 7, and it will be e to the power 5x upon 5 and plus some constant. Now we'll take everything on the right hand side. We can write 7 into e to the power 5x plus 5 into e to the power minus 7y and plus some constant, say c dash equals 0. Now we are given this initial condition that when x is 0, y is 0. So if we'll put x as 0 and y as 0, then we'll get c dash as minus 12. So answer to this question will be 7 into e to the power 5x plus 5 into e to the power minus 7y, and this value, it should be 12. And that's your option number C. Question number 9 is, we are given this summation aj, and then we'll need to find this limit n tends to infinite. Now first we'll write a0. Now a0 is I varies from 1 to n, and then I to the power 0. I to the power 0 is 1, and summation of constant is simply n. So a0 is n. Now what is a1? a1 is simply summation I, so it will be n plus 1 upon 2. Now what about a2? a2 will be summation I square, so it will be n plus 1, 2n plus 1 by 6, and a3 will be summation I cube, which is n plus 1 upon 2 whole square. Now we'll solve this limit, which is limit n tends to infinite a1 a2 upon a0 a3. So this limit will be limit n tends to infinite. Now a1 is n plus 1 by 2. What about a2? a2 is n plus 1, 2n plus 1. We write this as 2 and 3. And then a0, it will be simply n, and a3 will be n plus 1 upon 2 whole square. So it'll cancel. So this limit will be limit n tends to infinite 2n plus 1 upon 3n. So answer to this limit will be simply 2 by 3, and that's your option number B. Now question number 10 is, let PQR be real numbers, and if fx equals px square plus qx plus r such that p plus q plus r equals 3. So it simply means f1. Now f1 will be 3, and it is also given that fx plus y is equal to fx plus fy plus xy. For all xy belongs to r, we need to find the value of f5. Now first we'll find f2. So f2 will be 1 plus 1. It will be f1 plus f1 plus 1. Now f1 is 3, so it will be 3 plus 3 plus 1. So the value of f2 is 7. Now from f2 we'll find f4. So f2 plus 2, it will be f2 plus f2 plus 2 into 2. Now it will be 7 plus 7 plus 4. So it will be simply 18. So value of f4 is 18. Now we can write f5. So f4 plus 1, it will be f4 plus f1 plus 4 into 1. Now f4 is 18, f1 is 3, and plus 4. So it will be 22 plus 3, that will be 25, and that's your option number D. Now question number 11 is, if p and q are numbers such that p plus q is 1, we need to find this summation. R varies from 0 to n, r square ncr, p n minus r into q to the power r. So we write binomial expansion of p plus q to the power n, and it will be this summation. R varies from 0 to n, ncr, p to the power n minus r into q to the power r. Now what we'll do is, we'll partially differentiate it with respect to q. We can write n into p plus q, n minus 1, and it'll be r varies from 0 to n, ncr, p to the power n minus r, and r into q to the power r minus 1. We'll need r square. So we'll need to restore the power to r again. So we'll multiply everything with q. So we can write nq into p plus q to the power n minus 1, and it'll be this summation. R varies from 0 to n, and then this r, ncr, p to the power n minus r into q to the power r. Now we'll again partially differentiate it with respect to q. So here we'll use product rule. So it'll be nq, and then n minus 1 p plus q to the power n minus 2 plus p plus q n minus 1, and then it'll be this n, and here we'll get this as r varies from 0 to n, r square ncr, p to the power n minus r into q to the power of r minus 1. Now here in the question we'll need q to the power r. So again we'll multiply everything with q, And we also know that P plus Q is 1. So we can write this as N minus 1 into Q square plus N into Q, and it will be this summation. R varies from 0 to N, R square NCR P to the power N minus R into Q to the power R. Now here we'll take NQ common. So we'll take NQ common, then we can write NQ minus Q plus 1, and 1 minus Q is nothing but P. So it will be NQ into NQ plus P. So this answer will be N square Q square plus NPQ. And that's your option number C. Now question number 12 is, if mod of Z plus 3 minus 2 iota equals 8, then the minimum and maximum value of mod 2Z plus 9 minus 8 iota are alpha and beta. We need to find the value of alpha plus beta. Now this first equation, it represents a circle whose center is at minus 3 plus 2 iota and whose radius is 8 units. So we have this circle whose center is at minus 3, 2 and whose radius is 8 units. Now we need to find maximum and minimum value of this expression. So what we'll do is we'll take 2 common. So it'll be Z and then plus 9 minus 8 iota upon 2. We can write this as 2 into Z minus, and then it'll be minus 9 by 2 plus 4 iota. Now we know that any modulus in complex number is nothing but distance. So this is distance between Z, which is any point on this circle, and this point, which is minus 9 by 2, 4 iota. So we have this point, and which will be minus 9 by 2, 4. Now we need to find maximum and minimum value of mod Z minus 9 by 2 plus 4 iota. So what we'll do is we'll first find this distance D, and then minimum value of this mod Z minus this value is R minus D, and the maximum value will be simply R plus D. So this value will be simply 2 times and then R plus or minus D. So here alpha will be 2 R plus D and beta will be 2 R minus D. So first we'll calculate this distance D. So here this D will be under root of, now it will be 3 minus 9 by 2 whole square plus 2 square. So it will be 6 minus 9, 3. 3 square is 9. So it will be 9 by 4 plus 4. So it will be simply 5 by 2. So now we have D and we also have radius, which is 8. So this alpha will be 2 times and radius is 8 plus 5 by 2. So it will be simply 16 plus 5, and that should be 21. And here it will be 2 times and then R, which is 8 minus 5 by 2. So it will be 16. 16 minus 5, that is 11. Now we need to find the value of alpha plus beta. So it will be simply 21 plus 11, and that should be 32. And that's your option number D. Now question number 13 is, consider a cubic equation x cube equals 2x plus 5. Then which of the following statement about equation is true? So we'll need to find nature of its roots. So we'll take this function fx as x cube minus 2x minus 5. Now if we'll find f dash x, it'll be 3x square minus 2. Now the critical points are x equals plus minus root 2 upon 3. So this is minus root 2 upon 3, and here will be plus root 2 upon 3. Now rightmost is plus, so it will be plus minus n plus. So at minus root 2 upon 3, it will be a point of local maxima, and at plus root 2 by 3, it will be a point of local minima. Now we'll also need to find its local maximum value. So we'll find f minus root 2 by 3. So it'll be, we'll take this x common, so it'll be minus root 2 by 3, and then it'll be x square. X square will be 2 by 3 minus 2 and then minus 5. So it is 4 by 3 into root 2 by 3 and then minus 5. Now we are not interested in the value, but what we know is this value is less than 0. So its local maximum value will be a negative value. So we'll draw this approximate graph. Then we know that since it is a cubic equation, it will start from minus infinite, and then at minus root 2 upon root 3, it will take its maximum value, and then at plus 2 upon root 3, it will take its minimum value, and then it'll go towards infinite. So this function, it intersects x-axis only at one point, and that too when x is greater than 0. So this equation will have one real root, and that real root will be positive. So answer to this question is option number B, that it has one real root and a pair of complex roots. Now question number 14 is, if we are given two real valued sequences xn and yn such that xn cube minus yn cube, it approaches 0 when n tends to infinite, then which of the following is true? So what we'll do is, we'll write xn cube minus yn cube as xn minus yn into xn square plus yn square into xn into yn. Now what we'll also do is, we'll multiply everything with 4. So we can write 4 and then mod of x cube minus y cube, it is equal to mod of xn minus yn, and here we can write this as xn minus yn whole square plus 3 times xn plus yn whole square. Now this expression, it will always be greater than or equal to mod x minus mod y cube. So from here we can say 4 xn cube minus yn cube will always be greater than or equal to mod xn minus mod yn whole cube. Now when n tends to infinite, this sequence, it approaches 0. So this sequence, it must also approach 0. That means as n tends to infinite, xn minus yn approaches 0 always, and that's your option number A. Now question number 15 is, derivative of px is e to the power sin x upon x, which simply means integration of e to the power sin x upon x dx will be this px. Now we are given that this integral, which is from 1 to 2 3 upon x e to the power sin x cube dx is equal to pk minus p1, then which of the following is a possible value of k? So what we'll do is, we'll multiply numerator and denominator with x square. So now we'll take x cube as t. So we can write this as e to the power sin t dt upon t. Now when x is 1, t is 1, and when x is 2, t is 8. Now we know that integration of e to the power sin x upon x is px. So it will be simply pt from 1 to 8. So we can write this as p8 minus p1. So one of the possible values is 8, and that's your option number B. Now question number 16 is, we need to find distance of this point from this plane measured along a line parallel to this given line. So we are given this plane whose equation is x minus y plus z equals 11, and then we are given this point which is 1 minus 2 3, and we do not need perpendicular distance, we need distance measured parallel to this line, which is x by 2 equals y by 3 equals z by 6. So we have to measure this distance parallel to this line. So we want this distance. Let this point be A and this point be B. So first we'll write equation of AB. So we have a point and we also have direction ratios. Equation of AB will be x minus 1 upon 2, y plus 2 upon 3, and z minus 3 upon 6. Now we need to find point of intersection of this line and plane. So we'll take any point on this line in terms of parameter lambda. So let the coordinate of point B be 2 lambda plus 1, 3 lambda minus 2, 6 lambda plus 3. Now this point B, it is intersection of this line and plane. So this point B will also lie on this plane. So we'll put the value of x, y and z. We'll get 2 lambda plus 1 minus 3 lambda plus 2 plus 6 lambda plus 3, and it is 11. So it will be 8 minus 3 5. So it will be 5 lambda and then 6. 11 minus 6 is 5. So value of lambda is 1. So we'll put value of lambda is 1. We can write coordinate of this point B as 3, 1 and 9. Now we can find this distance AB using distance formula. So this distance AB will be under root of, now 3 minus 1 2, 2 square is 4, Now 1 plus 2, 3. So it will be 9. And plus 9 minus 3, 6. 6 square is 36. So 40 plus 9, 49. So this distance will be 7. So distance of this point from the plane measured along this given line is 7 units. Now question number 17 is number of words that can be constructed using 10 letters of English alphabet such that all 5 vowels appear exactly once. So that means we have to form a 10 letter word. And out of these 10 letters, it will have 5 vowels, and these vowels, they appear exactly once. So that means we'll have A, E, I, O and U. So we have 5 vowels, and for these 5 vowels, we need 5 places. So from these 10 places, we can choose 5 places in 10C5 ways, and in the chosen places, we can arrange 5 vowels in factorial 5 ways. So now we have arranged these 5 vowels at some 5 places. Now we are left with remaining 5 places. Now these remaining 5 places, they have to be filled by consonants. So we have altogether 21 consonants, and for consonants there is no restriction. So any consonant can appear any number of times. So for this first place, we have 21 choices. For this second one, again 21. For third, 21, 21, and fifth, 21. So these consonants, they can be arranged in 21 to the power 5 ways, which is nothing but 10p5 into 21 to the power 5, and that's your option number C. Now question number 18 is this function f, it is defined from 0 to infinite 2r, and let it be a differentiable function such that value of f0 is 1. Now it is given that fx into f dash x, it is greater than 0. So it simply means that if fx is greater than 0, then f dash x is greater than 0. So if fx is positive, then f dash x is greater than 0. So it means this function fx is an increasing function. Or when fx is less than 0, in that case f dash x should be less than 0. So if fx is negative, then fx is decreasing function. Now domain of this function is from 0 to infinite. So at 0, this value is 1. So this value is positive. When the value is positive, so that means this function will be an increasing function. So this value will increase from 1. So it will again be positive. So this function will always be an increasing function. Now we have defined this function an as area of the region bounded by x-axis and the y-axis and graph of f and the line x equals n for some value n. So we know that this area, it will be simply this integral from 0 to n and then fx dx. Now since fx is an increasing function, this area is also an increasing function. So the function area from n to r is an increasing function, and that's your option number A. Now question number 19 is if x, y, z be 3 natural numbers, then number of triplets x, y, z such that x into y into z is 100. We can write x, y, z as 100, which is 2 square into 5 square. So we'll take x as 2 to the power a1 and 5 to the power b1, y as 2 to the power a2, 5 to the power b2, and z as 2 to the power a3 into 5 to the power b3. So we'll replace x, y, z with these values. We can write a1 plus a2 plus a3 into 5 to the power b1 plus b2 plus b3, and it should be equal to 2 square into 5 square. So we'll compare, we'll get a1 plus a2 plus a3, it is equal to 2, and b1 plus b2 plus b3, it is also 2, and we need to find number of non-negative integral solutions. So we know that number of non-negative integral solutions is given by n plus r minus 1 c r minus 1. So it will be 3 plus 2 5, 5 minus 1 4, so it will be 4c2, and 4c2 is 6. For this also we'll get 4c2, which is 6. So total number of solutions will be simply 6 into 6, and there will be 36, and that's your option number B. Now question number 20 is how many distinct straight lines can one form that are given by an equation ax plus by equals 0, where a and b are numbers from this set 0, 1, 2, 3, 4, 5, 6 and 7. So we need number of distinct straight lines. So we'll take this first trivial case when either a is 0. So if a is 0, then all the lines they'll be of the form y equals 0, or when b is 0, then all the lines they'll be of the form x equals 0. So when a or b they are 0, we'll have two lines in this case. Now we'll consider the second case when both a and b they are unequal to 0. Now what are the possibilities of distinct lines? So we can write this line as y equals minus ax upon b. Now if we'll take a as 1, then we can take any value from 1 to 7. So there'll be 7 such lines. If a is 2, then we cannot take all the values from this set. We can only take the values which are co-prime with 2. So the numbers which are co-prime with 2 are 1, 3, 5 and 7. So there will be 4 such numbers. Now for a equals 3, again we need numbers which are co-prime with 3. So it will be 1, 2, 4, 5 and 7. That means 5 values. For a equals 4, we'll get 1, 3, 5, 7, again 4. For a equals 5, it will be 1, 2, 3, 4, 6 and 7. There will be 6 values. For a equals 6, we'll get 1, 5 and 7. That is 3 values. And for a equals 7, it will be 1, 2 up to 6. So again it will be 6 values. So what are the total number of lines that can be formed? So it will be 2 plus 7, 9, 9 and 9, 18, 22, 22 and 6, 28, 28 and 3, 31, 31 plus 6, 37. So total number of such lines will be 37, and that's your option number C. Now question number 21 is, consider 3 non-zero matrices A, B and C such that A, B, B transpose is equal to C, B into B transpose. Then which of the following statement is necessarily true? Now we can write this as AB minus CB into B transpose, and it is equal to 0. We'll multiply it with A minus C transpose. So we can write AB minus CB into B transpose, and then A minus C transpose equals 0. So we can write this as AB minus CB. Now B transpose into A transpose is AB transpose. So we can write this as A minus C into B transpose, and it is equal to 0. So we can write AB minus CB, and it will be AB minus CB transpose, and it is equal to 0. And we know that if A into A transpose is 0, it implies that this A is 0. So from here we'll get this condition as AB minus CB, it should be 0. That is, this product AB must be equal to CB, and that's your option number A. Now question number 22 is, if M and N are non-zero integers, then define AMN as n square x cube plus 2020 x square plus mx equals 0. Then number of pairs of Mn for which AMN has exactly 2 points is. So that means this equation should have exactly 2 roots. We'll take x common, we'll get n square x square plus 2020x and plus m, it is equal to 0. So one of the root is 0. Now for this equation, n square x square plus 2020x plus m equals to 0. 0 cannot be the root because m and n, they are non-zero integers. So this equation will have exactly 2 points when this quadratic equation has equal roots, and the condition for that is value of d must be 0. Now we'll find d. D will be b square, and there will be 2020 whole square minus 4 n square m, and it should be 0. So from here we can write 4 n square into m, and it should be 2020 whole square. So we can write n square into m as 1010 whole square. So it will be n square into m, and there'll be 101 square, and then 2 square, and then 5 square. Now we need to find how many solutions are possible for this equation. So first case can be when the value of n is plus or minus 1. When the value of n is plus or minus 1, then m will be simply this value, which is 101 square into 2 square into 5 square. Now other case can be when the value of n is simply plus or minus 101. In that case, we'll have this m as 2 square into 5 square. N could be plus minus 2. M will be 101 square into 5 square. N could be plus minus 5. In that case, M will be 101 square into 2 square. And then N can also be combination of 2. So it can be either 101 into 2 or 101 into 5 or 2 into 5, or N could be plus minus 101 into 2 into 5. So how many cases do we have? We have 1, 2, 3, 4, 5, 6, 7, 8, and 8 into 2 is 16. So there'll be 16 such cases. So the number of pairs Mn will be 16, and that's your option number C. Now question number 23 is, consider two independent events with the same probability P. The probability of occurrence of at least one of the two events is. So we'll take this probability as F, some function of P, and we'll need to find probability of A union B. So it'll be probability of A plus probability of B minus probability of A intersection B. Now both these probabilities, they are same, so it is P plus P and then minus. Now since these two events, they are independent, we know that PA intersection B is PA into PB, so it will be simply P square. So this probability will be 2P minus P square, which is nothing but a parabola opening downwards, which is always concave down. So it is strictly concave in P, and that's your option number C. Now question number 24 is, let S be a set of all 3 cross 3 real matrices such that A is Aij and such that the matrices Aij cube has rank 1. If we define the set R as rank of A, then R is equal to which of the following? Now we'll prove this question using contradiction. So what we'll do is, we'll assume that let the rank of A be either 2 or 3. Now if the rank of A is 2 or 3, then we can find two linearly independent columns of A. Suppose these columns are A1 and A2. So these two columns, they are linearly independent. Now for this matrix, which is Aij cube and which is say B, we are given that its rank is 1. So if its rank is 1, then no two columns for this matrix, they are independent. So in that case, we can write A1 cube is equal to C into A2 cube. Now we can write A1 as C to the power 1 by 3 into A2. Now from this condition, we can say that A and 2, they are linearly dependent. But if the rank is 2 or 3, then they have to be linearly independent. So there is a contradiction. So that means rank of A cannot be 2 or 3. So the only rank of A possible in this case is 1, and that's your option number D. Now question number 25 is, for this function, we'll need to find its continuity, differentiability, and continuity of f dash. Now limit x tends to 0 positive e to the power minus 1 upon x will be e to the power minus infinite, which is 0, and f 0 negative equals f0 is also 0. So that means fx is continuous at x equals 0. So this function, it is continuous. Now what about its differentiability? F dash 0 negative will be simply 0. We'll find its right hand derivative. F dash 0 positive will be limit h tends to 0 e to the power minus 1 upon h minus 0 upon h. So we can write this as limit h tends to 0 1 upon h upon e to the power 1 upon h. So which is infinity upon infinity form. We can use L'Hopital's rule. So it will be limit h tends to 0, and then it will be minus 1 upon h square e to the power 1 upon h and minus 1 upon h square. So it will be 1 upon e to the power infinite, which is 1 upon infinite, it should be 0. So left hand derivative is 0, right hand derivative is 0. So that means fx is differentiable at x equals 0. Now what about continuity of f dash x? So we'll find f dash x will be e to the power minus 1 upon x and then plus 1 upon x square, which is not defined at 0. So this function is continuous and differentiable, but f dash is not continuous, and that's your option number C. Now question number 26 is, for a cyclic group G of order 12, number of subgroups of G is. So we know that number of subgroups of G is equal to number of divisors of this order 12. So we can write 12 as 2 square into 3. Then number of divisors will be 2 plus 1 into 1 plus 1, and there will be 3 into 2, that is 6. So the total number of subgroups will be 6, and that's your option number C. Now question number 27 is, we need to find this limit, which is limit x tends to 1, and we can write this as limit from 4 to fx 2t dt upon x minus 1. Now we'll put x as 1, denominator is 0. Now here it will be f1 and f1 is 4. So from 4 to 4, this integral is 0. So it is 0 upon 0 form. So we can use L'Hopital's rule. So we can write limit x tends to 1, and then we can differentiate it using Newton-Leibniz formula. So it will be 2fx into f dash x minus 0 upon 1. Now we'll put x as 1. So it will be 2f1 into f dash 1. Now what is the value of f1? f1 is 4. So it will be simply 8 f dash 1, and that's your option number D. Now question number 28 is, we are given this series and we need to find whether it is convergent or uniformly convergent in the given intervals. Now we know that fx can be written as this summation n varies from 1 to infinite 2 to the power n x to the power 2 to the power n minus 1 upon 1 plus x to the power 2 to the power n. Now we can write mod of 2 to the power n into x to the power 2 to the power n minus 1 upon 1 plus x to the power 2 to the power n less than or equal to 2 to the power n into mod of x to the power 2 to the power n minus 1. If we consider 2 to the power n as some k, then we can write this is less than or equal to k into mod of x to the power k minus 1. And we know that this summation n into mod of 1 upon 2 to the power n is a convergent sequence. So answer to this question will be, it will be uniformly convergent on minus 1 by 2 and plus 1 by 2, and that's your option number D. Now question number 29 is, let S and T be two non-empty sets and f be a function from S to T such that f A intersection B is equal to f A intersection f B for all subsets A and B of S, then which of the following is correct? Now option C is f is 1 1. So what we'll do is we'll let f is not 1 1. That is f is many 1. So if f is not 1 1, then there exists 2 points x1 and x2 such that fx1 equals fx2, where x1 and x2 they belongs to S and x1 is unequal to x2. Now we define two subsets. One of the subset contains x1 and the other subset contains x2. So let this be A and let this be B. Now if we find f A intersection B, it will be f and then x1 intersection x2. Now intersection of x1 and x2 is phi. So it will be f phi and f phi should be phi. But on the right hand side, if we find f A intersection f B, now f A is fx1 intersection fx2. Now since fx1 is equal to fx2, so this value will be simply fx1 equals fx2. So that means here f A intersection B is not equal to f A intersection f B, which is a contradiction because in the question it says f A intersection B must be equal to f A into f B for all subsets. So that means our supposition is wrong. So f has to be a 1-1 function, and that's your option number C. Now question number 30 is, let x1, x2 and xn be distinct reals. Determine a set A, f1t, f2t and fnt such that fkt is 1 if xk is less than t and it is 0 otherwise. So if we take k as 1, then this f1t will be 1 when x1 is less than equal to t, and it will be 0 when x1 is greater than t. So we have this number x1. So if we take any t which is less than x1, in that case this function will take value 0 in all such intervals, and when t is greater than equal to x1, it will take the value 1. Now we need to find number of distinct elements in this set A. Now set A is this f1t, f2t and fnt. Now first we have n distinct real numbers. Now these real numbers, they'll be in some order. So let this order be xi, then xj, xk. This way we have placed all these n numbers. Now if we take any t in the leftmost interval, then in that case this t will be less than all these xi's. So here this value will be 0, 0, 0, 0 and n. Now if we take t between xi and xj, then here parity of xi will change. So that means all their values will be 0 except at x0. Now again for xj, parity of xj will change. So if we cross one distinct real, the parity will change for that real expression. So if we place n roots, we'll get n plus 1 intervals. So in each interval, we'll get a different arrangement of zeros and ones. So this A contains exactly n plus 1 distinct elements. Now we can verify it also. So if we take n as 1, then this set A contains only f1t. So there'll be only two such cases possible, 1 and 2. So it will have exactly n plus 1 distinct elements, and that's your option number D.